Try number 7.
Did you say number 7?
Yeah, please. So you drew your mirror like this.
Yeah.
I guess your reasoning is that the sun's rays would be coming in from above, right? Okay, that actually seems like good reasoning. I'm already getting confused
Yeah, me too.
about the fact that it looks different. So let's just suppose that the sun is down at the horizon.
Okay.
If the sun was at the horizon, if the sun was on the horizon, then we could hold the mirror like this.
Mm-hmm.
And the rays would come in horizontally.
I got R equals positive 36 centimeters. Do you want to be sure and put your positive sign with the 18?
Now remember that this formula is only based on magnitudes.
Okay.
Since magnitudes are always positive, it's probably better not to put a sign in, because that would suggest it could be either positive or negative. Okay, but it's good that you're thinking about the signs over there. Now remember, this formula just gives us the magnitude of R. So again, I won't say this is positive 36. I'll just say it's 36 centimeters over here. And actually, as far as your course is concerned, we won't worry about the signs for radii of curvature. All we need is the magnitude of the radius of curvature. So in this case, we can just say that the radius is 36 centimeters.
Correct.
Okay, I thought that question was pretty difficult, but didn't give you too much trouble, so that's good. So let's see what the logic for that was. Now, how did you know that all the rays here were coming in parallel to the axis?
Because of the sun's distance.
Which is near infinity. It's not really infinite, but it's so far away, we can approximate it as infinity. So you got to watch out for this on the exam. If it seems like the object is really far away, maybe you're supposed to approximate the object distance as infinity, especially if they don't tell you the object distance. Again, a lot of people would look at this and say, gee, this isn't fair, they didn't tell me the object distance. Well, that's because we're supposed to approximate it as infinity. All right, and then we know that all of the points go out through the focal point. So when they told us that all the points were coming out through this point, we know this is the focal point at 18 centimeters, and then you could just jump straight to this equation over here. Very good. By the way, you can see how this is going to work. Is this a real or a virtual image here? Now, a real image is on the same side as the outgoing light, and a virtual image is on the opposite side of the outgoing light.
It's a real image.
Which side is the outgoing light on?
The left side.
And which side is the image on?
The left side.
That's always the best way to work it out. So that's right, this is a real image. Another way to think about a real image is, if there's somebody looking from over here, it will seem like the light is coming from this point. But is there actually any real light passing through this point? Well, yes, there really is light passing through this point. This is not virtual, this is real. There really is light going through here, and this is the reason you could actually cook something, by putting it here. If we actually put some food over here at this point, it's going to actually feel the heat from these light rays passing through it. So can you cook something with the light rays from a real image? Yes. Can you cook something with the light rays from a virtual image? No, because there isn't actually any light there, so that would be a good application for a test question. Okay, remember this is all supposed to be a solar cooker. Well, we can see a solar cooker has to work by making a real image. Okay, and it's making all these light rays converge over here. Just to remind you, all that you did there was just kind of a shortcut for using the lens mirror equation. Since the sun is at infinity, we could just plug in infinity over here for object distance. Then this would cancel out, and then we know the focal point is 18. And once you know the focal point is 18, you can plug it into over here. But because we just memorized these rules, these are just a shortcut to what we could also get from the lens mirror equation here.